Hi, Sabir. Hi, everyone.
Hi, good evening.
Good evening. Good evening. Okay, so what we're going to discuss today? Let me share my screen. Then we are going to discuss this step by step all the concepts. All right. Just one more minute. Let me see my settings. All right. So I believe we are good to start. Where was my copy paste? Okay, ठीक है. So let me share my screen. I hope it's visible, my screen, right? Is it?
Yes, sir.
Okay, good. So we'll back to the EIGRP topic again, and we have to make a progress from yesterday class. So I will go and I'll open this EIGRP topology, and I'll turn on the labs. I'll just start the lab. Okay, so very first thing, guys, we have to understand. Let me see recording is on or not. That must be on. Yeah, it's on. So what we have to understand, the key concept, right? I discussed few things yesterday, right, about the packet, how it is going to be exchanged, how the hello packet is going to be exchanged between the IGRP and neighborship. And also we discussed inside the packet, what all information is going to exchange by the IGRP. Now we have to understand the method by using that. Even you can see this all packet now showing that hello, acknowledgement and acknowledgement, update, update packet in acknowledgement. But most important, what we have to understand is the calculations. Whenever you go for the EIGRP, how the EIGRP is going to do the route calculation. So we have the different terms. We have the successor term, we have the feasible successor term, we have the feasible distance. So what is this all parameter and why it is very important? That we have to understand one by one. So very first thing, if I talk about the successor, let me use my whiteboard so I can explain you in the better way. So in EIGRP, what is going to be happen? Let me go here. So EIGRP use the different method, right, to just calculate the route. Let me put it here. So let's suppose this is my one router. This router is connected with another router R2. This is going to connect with the R3, right? The another path is R4, this R5, and this R6, and this R6 further connected with the one network. Might be this is the network, or think about this is the router, not network. Just think about this is the another router, the R7. So basically, to reach from this subnet and to this subnet could be the 7.7.7.7/32. How the EIGRP is going to use the calculation? So they use the successors. The first term they use the successor. Now the second term they use the feasible successor. So what is a successor and what is a feasible successor, and why they are going to play a very important role here? Also they use one other term, that is the feasible distance. Sorry, they use the feasible distance. This is known as the FD. Also they use the term that is the AD, or it is known as the RD. AD is equal to advertised distance, RD is equal to reported distance. So you guys just note it. AD is equal to advertised distance, RD is equal to reputed distance. And one more term they use, that is going to be your feasible. This is going to be my feasible conditions. Okay. So what is successor? What is a feasible successor? What is my feasible distance? What is my reported distance and advertised distance? And what is my feasible success? I mean feasible conditions. We have to understand. So as we discussed that EIGRP basically use the composite matrix, and this composite matrix based on the K1. This is going to base on the K2, K3 and K4 and the K5 value, which we'll discuss later on how it is going to happen. But for time being, let's understand the successor. What is the meaning of successor? Successor is basically, it's going to define your best path to reach the destination. It is going to give the best path for any destination IP. This is a successor. Means if I have successor, it is going to tell what is the best path, which is my best path from where I can reach to destination. Feasible successor is going to be your backup path, means second best path. You can just put it second best path. This is going to be your feasible successor. Now we'll discuss about the feasible distance and advertised distance later. But let's understand, if I want to go from here to here, this is cost is 2, this is the 3, this is the 9, and this path, let's suppose cost is 1, 2, 2, 4. So which path cost is higher and which path cost is lower? Can you guys tell me?
Bottom path.
Path 2, right? So if you calculate, it is going to be 1, 2, 2 plus 4. What is going to happen? It's going to be 9. This is my path 1. And if I go this path 2, 2 plus 3 plus 9, it is going to be 14. This is my path 2. So this path is going to become my successor path because this is the path which have the lowest metric to reach the destination. And this is going to become my feasible successor. If I have, let's suppose, another path also available here. Let's take an example. I have the third path also. Let's suppose this is connected with the R8 and this is my R9 and this is connected. Now this having a metric 10, this having the 5, this having the 6. So if we add, this is going to be total 21. The total cost is going to be 21. So this is not going to be your second best path. This is your second best path. Although we have the 3 path, but successor is going to be your best path. Feasible successor is going to be your second best path. Now we have to understand, is it clear, right? Successor versus feasible successor. It's clear to everyone?
Yes, sir.
No doubt. Tarun, you clear also?
Yes, sir.
Okay. Now we have to understand how this successor and feasible successor are going to be used, right? So the only conditions, they are going to select your best path, nothing more than that. Means they are just simply going to select your best path, and based on that they are going to just make sure your routing table have the primary path route and secondary path route, and they will just going to be switch the traffic in case of my primary path is going to fail. That is the goal of the successor and feasible successor. Then what is the feasible distance? Feasible distance is going to say, right, whenever you have any kind of the like FD, the feasible distance is the best metric or best path metric. Whenever you talk about the feasible distance, it is going to be lowest metric of your source to destination. Means from here to here, which one is the my best metric? This one, right? So this is going to be your feasible distance. Means lowest metric from source to destination is going to be your become the feasible distance. Means whatever successor path metric is going to be your feasible distance. That is your feasible distance. What is advertised and reported distance? That's quite confusion. Your feasible distance should be always greater than your advertised and reported distance, or you can say in this different way, your basically RD and AD should be always lower than your feasible distance. So let me just explain this concept because it's quite complicated. So hold on. How can I clear? So I simply clear the board and then we'll talk about the feasible distance versus we'll discuss about advertised distance and reported distance. Think in this way, we are talking about the feasible distance. And we have the advertised distance. Also, this is known as the reported distance. So what is this difference between these two? So my feasible distance is lowest metric for any destination. That's my feasible distance. Nothing more than that. Means lowest metric is going to be my feasible distance. Nothing more than that. Means whatever my any PC is going to reach to any destination via any routers, whatever the my lowest path, that is going to act as my feasible distance. But when I talk about the advertised distance, that is quite confusing, and reported distance is also going to be quite confusing. So let's understand in the topology format so you guys can understand easily what is the meaning of that. So I'll use again R1. This R1 is going to connect with the R2, and this is going to be R3, and this is going to be my R5. Okay, this is the one path. This is going to connect with the R6 and then R5. Now this router have one feasible distance, and what is that feasible distance? The metric. Let's suppose this is metric is 4, this is the 3, this is the 2, this is the one thing, this is the 4 and 4. So what is the cost of this path? Total metric, this is going to be 4 plus 4 is going to be 8, and this is the cost or metric. Cost is not correct word, we should use the metric. Metric is going to be 4 plus 3 plus 2, it is going to be 9. So for this router point of view, they have the successor. This router, this is going to be a successor which is going to best path, and this is going to be a feasible successor. So one is going to be successor and one is going to be feasible successor. Successor is going to be 8 metric, feasible successor is going to be 9 metric. That's two things is going to happen. But before it's become the feasible successor, right, they have to meet the feasible conditions. Means what is the feasible conditions? Feasible conditions. Before it is going to select the feasible successor, it must be meet the feasible condition. And feasible condition says your RD or AD should always lower than your FD. This is a feasible condition. Even your RD or AD should be always lower than the FD. Or another word, FD should be always greater than your reported distance or advertised distance. Both meaning is same. Then only it is going to be choose your feasible conditions. Till now it is clear, guys. I hope it is clear, right? Any doubt till here? Please let me know. We are good, na, till now?
Yes. So how we can calculate this RD
I'm
and
going to
AD?
tell how it is going to calculate. I'm going to tell it. But at least we understand now what is a successor, what is a feasible successor, what is a feasible distance, what is a feasible condition, how it is going to meet. Now, you guys know what is my FD. Feasible distance is going to be, let me use a different color. It is going to be my 8, right? But this path before becoming the my backup feasible successor, they have to meet the feasible conditions. That's the key things, and we have to follow this rule. So in this router, they have two neighbor, the R2 and R3. They report if I want to go 5.5.5.5, if you go via me, I have a total metric 3 plus 2 is equal to 5. So it will report this. This is the reported distance is 5. If I go via this one, this is going to take reported distance, or it is going to known as the AD. Your neighbor is going to inform how much metric to reach these destinations. This neighbor is going to inform. Similarly, this neighbor is going to inform me if I want to reach there, I have only 4. So it will inform this will 4. So it will also inform this is going to be reported distance and AD is going to be my 4. Clear? So both neighbor, basically reported distance is going to be always reported by your neighbor, not by you. So this neighbor is going to report what is my feasible conditions. Okay. So now you see that in this router we have the two reported distance, advertised distance, means one from the R2 and R3. So if you compare, then this value 5 is less than 8 or lower than 8. Can you tell me, guys? Less than, right? This is the via R2. So via R2 my RD is this one, and via R6 what is my total reported distance? 4, and it is there. So this is my reported distance. So does both path meeting the feasible condition or not?
Yes, sir.
Both path meeting the feasible conditions. So in this case, this one already become my feasible successor because I have the lower path. This path is going to be eligible for the your backup path because it's meeting the feasible conditions. If it is going to be greater, how and which condition it is going to be greater? Let's suppose in different scenario. Hold on. Give me 1 second. Or let me clean this. Okay. Fully let me clean this. Okay. I'll clean this all and let me go again. So now let me tell again, R1 is there, R2 is there, and again R3 is going to be there. Again my R5 is going to be connected here. Okay. This is going to be again my R6 and R7, and this is connected here. Now this is going to 4, 2, 6. This is going to be 9, 10, and 2. Now you guys tell me, for this subnet, this is the 5.5.5.5. Which path is going to be my successor? R6 or R2? Which one?
R6.
R6, right?
Yeah.
So what is the total metric we have here?
12.
4, 2, 6. It's going to be 12, right?
Yes. Yes.
This is my path 1. And path 2 metric? What is the path 2 metric?
20. 10 plus 2 plus 10
21,
plus
right?
9. Yes.
2 plus 10 plus 9. It's
9.
going to be
20.
21. Okay. So now it's clear this path is going to become my best path, right? We all agree? This
Yes.
path is my best path, right? Best path. And it's known as the successor. Clear? Now this path is going to become feasible successor or not? What do you guys think? This path is going to become feasible successor or not? Sabir, you're getting background noise from your side. Little bit. As Tarun or Sabir might be, you tell me, this path will become feasible successor or not? What do you guys think? To become a feasible successor, they have to meet the feasible condition, right? FC. And what FC say? FC say your FD must be greater than your RD or AD. Okay, clear? So what is my total FD value? Who is going to tell me? What is FD value? What is my FD value here?
8.
No, feasible distance is total metric. Feasible distance is total metric. This total metric is always going to be feasible distance.
It will be 12. Yes.
Total metric, right? So this is going to be 12.
Well,
All right. And what is my reported distance from the backup path?
19.
90.
Is it meeting the feasible condition or not?
No.
No. So this will never go into your backup path because it's failed to meet the feasible conditions. So it's not necessary, even you have the backup path available, it is going to be always backup path. They must have to miss the feasible conditions. Then after it's going to be backup path. Okay, let me share my screen and then we'll see together all this concept. You guys able to see my screen, right?
Yes.
Okay, good. So here you see the successor route, the route with the lowest path metric to reach the destination. That is going to be my successor. And the successor is the first next hop router of the successor route, means your neighbor router always going to be successor, which is giving the my lowest metric to reach the destination. So R6 in this case was a successor neighbor. Feasible distance, first of all, feasible successor. Feasible successor route with satisfied the feasible conditions. You can see here, it's not always backup path is going to be your feasible successor. No, it's not going to be there. They must have to satisfy the feasible condition is to maintain the backup route. And what is the feasible condition? Feasible condition, your FD should be, feasible distance must be lower than your RD. Okay, let me see if I have one slide so I can show you. Hold on. Let me see if this slide have the all informations. Okay, hold on. Okay, so successor is the base route that is going to reach to your destination. EIGRP use the successor route for the traffic, right? And feasible successor is going to be backup route, means feasible successor is the backup route that EIGRP keep ready to use in case of the successor is going to fail. That is your feasible successor. But this feasible successor only going to be built if it is going to meet my feasible conditions. Okay. And what is the feasible distance? The total travel time or total metric. Feasible distance is the road, the cost or metric router reach to destination using the successor route, means from the successor how it is going to reach to my destination, that is going to my feasible successor, right? And EIGRP used to calculate the bandwidth and delay, means composite metric to calculate all the metric. And finally, what is my reported distance? Reported distance is AD, advertised distance or reported distance. Your neighbor router, whatever the metric they're reporting to the your actual from where you want to reach the destination, that is known as the reported distance. So always the reported distance, a distance metric reported by your neighbor router, that about how far this destination from me. So both are going to advertise the reported, and that reported distance used to just calculate the my feasible conditions. So this is, you can see about that, and then you can see feasible conditions, right? How to select the safe and backup route. Feasible conditions say your always reported distance, advertised distance should be lower than the advertised distance, means the feasible distance, or your FD should always greater than the reported or advertised distance. So that is what we just see, right? So I hope it is clear to everyone. Successor, best path, feasible successor, backup path, and feasible distance, total cost to reach the destination, right? And reported distance, neighbor advertised cost. Whatever the neighbor is going to advertise, feasible condition is going to be choosing the backup path based on the feasible condition deployment. It's a clear, guys? Any questions? Any doubt? How this is going to be happen? Feasible conditions and all examples. We'll see in the lab actually. So you can see in this lab also, if I just explain that. So if this R2 want to reach via this one, okay? So this is one path, this is the one path. So this path is going to be how much? 9 plus 4 plus 5. 18, right? This path. This is the path 1 via R3, okay? And via R1, 7 plus 3 plus 4 plus 5. How much it is going to be there? 10, 19
19.
via R1. So this one is going to your best, right? Best metric. This is going to your feasible distance. Feasible distance via this path is going to be 19. Feasible distance via this part is going to be 18. So which one is going to be your feasible distance? Lower metric. Finally, router is going to select this one. So this path is going to via R3 is going to become your best path. You can see even it is written here. This is 19, this is 18. And what is advertised distance? When this router will tell about this prefix, what is advertised distance? 5, 4,
7.
no, 7, 5,
9
12, right? 12,
and
no?
12.
12,
Yes.
right? So this is going to RD from this side. And what is RD from this side? Is going
9.
to be 9. So this is how it is going to there. So you can see it is 9. And then they will verify the lowest FD. Which one is the lowest? This one. So it will get the successor. This will become the successor. And what is the feasible successor? They will first check the feasible conditions. So what is the feasible conditions? So feasible condition, my RD is 12 and my FD is how much? 18.
9.
18, na? 18.
Oh, should check FD or should check RD?
No, RD, see, it's
Okay,
bit
RD.
confusing, right? RD is your backup path. This is become their base path, right?
Okay.
And they have already FD. Clear? 18. Now you're selecting the backup path. Backup path, before you selecting, you have to make sure whatever the backup path RD it is advertising should be lower than FD. So what is FD our case? 18. And what is
18.
RD? 12. So it's meeting
12.
the condition. Then it's going to become my backup path. Clear?
Yes,
Yes.
thank you.
In the diagram, the previously which we are working on, you mentioned that the backup path will not be installed because it's not meeting the feasibility condition, right?
Right, right.
In case of the link failure, like if the primary path goes down,
Then
so
it will become the best path. Definitely.
it will become the best. Okay.
Yeah, definitely it will become. But in that situation, it will never going to become if that feasible condition is not going to be. It's not going to install in the routing table.
Okay.
The backup path only going to install in the routing table as a backup if this is going to meet your feasible conditions. Clear?
Clear. Clear.
Now, so let's try to build the topology and understand more deeper side how it is going to happen. These all calculations. So let me try to build this lab. It's quite complicated, but let me start one by one. We'll try to assign the IP schema and all. I will try to simulate all the conditions of the EIGRP. R1. We'll go for the one by one. I'll assign the IP addressing and all. R2. And I'll go for the R3 first. I will not configure all the routers for time being. I'll go for the R4. We'll configure first 3, 4. Okay. And then I'll go for the R5. So we are going to target this area total. I'm going to target all this till here. Okay. We'll add this R6, R7 later on. But for time being, I'm just going to use this topology to just make sure EIGRP testing. This all I'm going to use, this entire thing. Later we'll see how it is going to use the other as well. Now I'll go in the R1 VIOS1 and configure my IP schema. So how the IP schema is going to be configured? You can see the R3, 1, 3, 1, 4, 1, 2. So I will do 1 here, 3 here IP, right? You can see if this is subnet, I'm going to use. So I will configure 1, 1, 1 here, but remote is going to 14. So 4 is going to have it. 13, 13, 3 is going to here. 2 is going to be here, right? Similarly, 3, 5. So 3 is going to be here. 5 is going to be here. 4, 5, 4 is going to here. 5 is going to here. 2, 5, 2 is going to here. 5 dot here. So you guys have to use the same way. Better way to just have the configuration. So I'll configure 0 by 1, 0 by 2, Okay, let me configure one by one all the interfaces. So do show IP interface brief. It's already configured. How? That's not good. Let me do from the scratch configuration. I don't want to put that configuration here. So I will remove all the configuration. I was thinking I wipe out all the configuration. Might be in the previous session it was there. Okay, never mind. I will do the configuration again. Okay, so let's see that how it is going to be done. Wait for a while, it will take a little bit time because I just restarted the router. No, I will go here as well. No, I'll go here as well. Come on, Aja bhai. Come on. Okay, no. This is the last one. Okay. So finally, one should be boot up. Yeah, it's booting up. We'll do from everything as scratch. No prior configuration I want to put in the router. So you guys have the better understanding how to do step by step all configuration. So still we are going to do everything in the classic mode, means EIGRP is going to configure in the classic mode. Finally. So I will go here, config T, right? I will first set the host name. That is a vios1. vios1. I'll copy it. I need to put every router by just changing the first. I need to change the host name for the all router. So configuration T, I need to go and I need to put vios2. I need to go here, enable config T. I need to go for the put vios3. I'll go here as well, enable config T. I'll put as a vios4. I will go here, config T, put the vios5. Okay, so this is just hostname assignment. Now I'll go and do the IP assignment on the interfaces. So very first 0x1, this is going to be 14. So I will go here, interface gig 0x0, not 1, 0x0. Okay. So 14, I will go here and put IP address 14.0.0.1 to 55 to 55 to 55.0. No shit. What is second interface? This is 0x1, 12. Okay. So I will go here 1 and it is going to be 12. I'll put no shut. What is third one? 0 by 2. This 3 we are targeting as of now. So I will go here 0 by 2 and this is going to be 13. If I'm not wrong, yes, 13. I'll put no shut here as well. All 3 routers done. What next? I will just do right. I will go in the VIOS 2. Do show IP interface brief. And in this 2 routers, you have 2 interface, one 0 by 1 and 0 by 2. So here I'll assign 12.2 and 25.2. So I'll go here, interface gig 0 by 1, sorry, IP address 12.0.0.2, 255.0, no shut. And I'll try to ping first my neighbor, whether it's pingable or not. I'll make sure my neighbor should be pingable. Then I'll move to the next step. Means .1 we configure in the my R1 router. Yeah, it's okay. Now I'll go and 0 by 2 and here I'll configure the IP address 25. 25.2. Okay, I'll put the no shut and do right. This is also done. Now this R2 done. Now I'll go for the R3. R3 again, do show IP interface brief. And we have the interface. If I go here, interface, we have the 0 by 2 and 0 by 0. So 0 by 2 have 13.3. Gig 0 by 2 IP address. Let me first ping 13.0.0.1 should be reachable. Let's switch. Yeah, it's reachable. Now I'll go and assign another interface. And this interface have 0 by 0, 35.3. Okay. And I will use the IP 35.3. I will use this one. This is done. And then I will just do right here. So do right. This is done. And after that, I'll go for the R2, R3, and R4. So this is my R4. Do show IP interface brief. And here I'll go in R4 interface 0 by 0 and 0 by 1. 14.4 here and 45.4 here. 0 by 0. Gig 0 by 0. IP address 14.0.0.4. And then I'll ping. Once this interface is going to be come up, I'll ping to my neighbor. And I'll make sure the R1 should be reachable. It should be reachable. Yeah, it's reachable. Now I'll go and configure the 0 by 1 and it is going to be 45.4. No shut and do right. Now I left with the last one router R5 and then we'll do the test point to all neighbor. Do show IP interface brief. In this we have the 3 interface 0 by 0, 0 by 1 and 0 by 2. Okay, let's start with the 0 by 0. Gig 0 by 0 IP address. What is IP address? 35.5. Please let me know guys if you have any difficulty to understand till here. We have to ping .3 because my peer is .3 and it's pingable. Now I will go and configure 0 by 1. 45.5 need to be configured here. So I will go here 0 by 1 and I will just change as a 45. Done. I will ping this one also. Let's wait. Interface come up and I will ping the neighbor. Sorry, 4. It should be reachable. Yeah, it is reachable. Now the next one is we left with this 25.5, 0 by 2. 0/2. Okay, and I'll ping 25.2. Sorry, not 1. Now we have to wait. We have to ping dot 5. Wait.
.2.
Dot 2, yes. Dot 2. My bad. Yeah, it's fine. So we all done the point-to-point reachability. Now we have to enable the EIGRP, and we can check how this EIGRP is going to build neighbor between each other. So definitely I will use the one of the, what I can say, the AS number for these all configuration, and that AS number I can take any number, and let's suppose I'll take like 100. Okay, so I will configure all 100 here. Means all routers should be the same AS because we are targeting this topology. And also we create the loop back 1.1 and 5.5, and we'll see how the behavior is happening between the my routers. So I will just here and create interface loopback 5, IP address 5.5.5, and another loopback I'll create here, interface loopback 1, IP address 1.1.1, 255, 255, 255, 255. Okay, do right. Let's enable the EIGRP. Very first thing, how this EIGRP is going to, let me remove these routers. I don't need. So let me delete this router for time being. So you guys not going to be confused. We'll add later on. Okay. So I just want to focus in this topology. Okay. So this is the final topology, and we want to do some testing. So very first thing, I want to enable the EIGRP. Again, we require the AS number. We decided to use the AS number router EIGRP 100. And this is the classic mode. We have to discuss the named mode later. And which network I want to enable. If I want to enable for the all network, so I just have to give 0.0.0. It will simply enable EIGRP for the all network, which is all interfaces which you configure on my EIGRP. You guys want to see that? Let me do that. I will paste this command, okay, to all the router. Let me show you. But you see how quickly that all is going to build a neighborship. I'll run this command R2 as well. Done. I'll go here. I'll put it done. And see, this is all start building the EIGRP neighborship. Done and done. And you'll see after some time, all EIGRP neighborship has been built. 3 neighborship is built. And if you go the R1 also, show IP EIGRP neighbor, it is going to build. So by default, the loopback we created, it is going to be reachable. So you guys don't have to do this way for doing this EIGRP configuration. This is the easiest way in the lab to enable the EIGRP, but this is not right way to do the EIGRP configuration. But if I want to ping now, you can see I am in the R1, and if I check the show IP route, you are going to find all EIGRP route. This is coming from all 3 path, right? You can see. So why it's all 3 path? Because all 3 are successor. Why they are all are 3 are successor? Jason?
They have same metric.
Same metric. And why they have the same metric? Because you can see the bandwidth type is same, because they
Links
use
are same.
the metric calculation. They use the formula that is known as the K1, K2, K3, and K4 and K5. That is going to use for the metric calculations. And if that is all is going to be same, then your metric is going to be same. It is not going to be changed. So by default, if you go into the EIGRP metric calculation, by default your K2 and it is going to be your K5 is going to be used for the metric calculation. So K1 and K3 is going to be for the metric calculation. Rest are going to be not in use. So let me, if I go here, and show you the matrix calculations. You'll go and find there. This is going to be topology. I'll show the topology table here where you're going to find the feasible distance, feasible success. I'll show you these all parameters. But if you go a little bit down and you go a little bit down, you're going to find the matrix calculation formula. So we have to understand that also. See here. So path matrix calculation, they use this formula, right? There is two matrix. One is the normal matrix calculation, one is the wide matrix calculation. So I'll discuss the normal. In wide matrix calculations, we have the K6 value as well. So, but just focus on the K1, K2, K3, and K5 and K4 value calculations. By default, K1 is equal to K1 multiply into bandwidth. This is the matrix calculation. Means K1, whatever the K1 value you have, you just have to multiply the, your bandwidth, right? Second, K2 multiply by your bandwidth divided by 256, okay, minus load. So by default, what is going to happen? This is going to use for, like, if you're going to do that, it is going to become a, like, not going to be used because we generally use this reference as a 0. So it is going to be 0. And this K3 into delay is a link delay. And then it is going to be K5 and K6. So if I talk about the K1, K2, K3 value formula, so let me explain that. So what happening, why it is going to be 0? So by default, when you go and do the K1, K1 is going to represent your bandwidth. And this value by default is going to be 1. Okay. This value is going to be 1. K2 is going to represent your load. By default, its value is going to be 0 unless you are going to define manually. K3 is going to represent your delay. This value is going to be 1, right? K4 is going to represent your reliability. And this is going to be 0. And K5 is going to represent your MTU. This is also going to be 0. So that's what I'm saying. If I'll go again in the book, okay. I hope you guys are able to see that. So if this is going to be K1 into 1. So this value is going to be always, because the K value is going to be 1. So whatever the bandwidth you multiply by 1, it is going to be some numeric value. But K2 multiply by bandwidth, this value is 0. Multiply anything 0 is become the 0. So this is going to be 0. K3 is 1. So K3 into delay. So it is going to give some integer number, some numeric value. So this value is going to be also. So K1 is going to be calculation. K2 is going to be calculation. K4 again it's going to be 0. K5 again is going to be 0. So they are not going to be considered as a matrix calculation. So by default, when you talk about that, it is going to be K1 and it is going to be K3 for the matrix calculations. We'll manipulate this value as well. But this is how it is going to be considered as the matrix. And if you want to see that, how this value is going to look like, if I go here and just run the command show IP protocol, you can see here. It's not saying me, it's saying by, you can see the router matrix weight. K1 value is by default 1. K2 is going to be 0. K3 is going to be 1. K4 is going to be 0. And K5 is going to be 0. So your MTU, your reliability, this is going to be delay, this is going to be your load, and this is going to be your bandwidth. So this is going to be 0, this is going to be 0, sorry, this is going to be 0 and this is going to be 0. So by default, matrix of the EIGRP is going to be always, that is going to be K1 and K3. It is clear, everyone? Default
Yes, sir.
matrix of the EIGRP. They use the composite matrix. But by default, K1 and K3 is going to be used. If you want to change, that is possible, but by default, it is going to be there. There is a K6 value also, it is going to be used. That is going to be used for the wide matrix calculation. I'll tell story of the wide matrix also. What is that? So now if I am going here in my router, you can see here show IP route. It is showing the 3 routes. Why 3 routes? Because all 3 are going to be come as a successor based path. They have the equal metric, equal kind of the distance. So if I go and check the another command, so IP EIGRP topology table, you will see that 3 successor you're having. And what is the FD? These are the FD. All having a 3 FD only. So it's a normal conditions. But let's suppose I want to manipulate the successor and feasible successor. Then what I have to do that? I need to play with some parameters. Make sense? Then only it is possible. So I want to make one path as a successor. Let's suppose I want to use this path as a successor, this path as a backup successor. And if this is going to be down, this is going to be my third successor. Means this is going to be feasible conditions, means feasible distance, best path, second best path, and this is going to third best path. But this only going to install 2 paths in topology table. One is the primary, one is the backup. Third one is not going to be there. So what I can do that, I need to play with the metric calculation formula. So yesterday we see that whatever my local bandwidth I'm configuring, that is going to use for the metric calculations. We agree, na? Yesterday we see that. Means I was configuring the bandwidth on the interface. One is the 1000 Mbps and one
Yes.
was going to be my like 900 Mbps. So this path was becoming the best. So similarly, because I need to play with the K1 value. K1 is basically bandwidth. K3 is equal to delay. I can play with the delay also. So I can put the lower delay this one, higher delay this one, and little bit more higher delay this one. So again, it is going to be manipulate my bandwidth calculation. But I'm going to use the bandwidth, which is the easiest way. So what I can do that, I will put this link bandwidth as a 1000 Mbps, right? This is going to be 900 Mbps and this is going to be 800 Mbps. So this path is going to be definitely best metric because K1 value is going to be always higher. This is going to be second best and this is going to be third best. Clear? Everyone, Tarun, Prashant, what I'm trying to make a point. You
Yes,
guys are
sir.
understanding the formula?
Yes, yes.
Okay, that's good. So let me go here and do the bandwidth. So by default R1, this link, show IP interface brief, I have a 3 links. So for this link, I will leave with the default. By default, every link have the same bandwidth. So interface, this one. So this is my have the how much bandwidth? 1000 Mbps. But for this one, I'll make the 900. This is 800. So what I can do that, I will go here config t interface, and I'll put the bandwidth 900 000. It's going to be an Mbps. And I'll go another interface 0 2. Okay, sorry, 02 should be 900. Okay, never mind. I'll make, okay, let me, okay, 01 I want to put as a 800. I want to make middle path as a best path. Okay. So I'm putting this one as a 800. I'll put this one as a 900. So I'll go here, bandwidth 000, 900, 1, 2, 3. Done. Now let's check it. If I just check show IP EIGRP neighbor, you're going to find I still have 3 neighbors. But if I check again show IP route, you're seeing only one best route. 2 are gone. Why? Because they check the successor conditions and found the lowest metric they are getting from this particular. This was an old metric also. See, this is the same metric earlier they're getting. where this route, see 131072. But now because I just changed the matrix, so two routes gone from the routing table because their matrix is different. And what is that matrix? I want to check. Then how I can check that? I can go here, show IP, EIGRP, topology. So there is a multiple table. In EIGRP neighbor table, topology table. So neighbor table is going to be carry all your neighbor informations. That is this output. This is going to be my neighbor table. This is my neighbor table. You can see. And this neighbor is going to be connect all neighbor information, adjacent neighbor information. But if I go this one, this is going to be my topology table. So this topology means this is a routing table, and this is the third one is topology table. This is going to carry your all topology, and you can see this is showing that we still have the three path, but you can see we have the different matrix. This one is a one matrix, this one is this matrix, and this one is this matrix. What is this value? Anyone know that? What is this value? If I check the routing table, this value is not there.
Reported distance?
Yes. So if I go, all are reporting the same distance. If I go here, this is the reported distance. So it is not mentioned in somewhere, but all router is going to report the, and so this is going to be your, which one is going to be successor? This one is successor, and this is going to be feasible successor. You can see this matrix is lower than this one because this was bandwidth was set as a 900, clear, and this was the 800. So that's why it is become my third feasible successor. So I hope you guys understand. So the calculation of the matrix based on the your total matrix, whatever the matrix is coming from the link, and the feasible successor is going to be backup part, but they must meet the feasible condition. So they all reporting this distance. This is the reported distance. Whatever you see that, this is the reported distance we have. And if I just run so IP EIGRP, let me interface. So these all three interface. Let me topology table summary. Okay, 8 routes. Detail links. Okay, the same output still we have. But just focus on this one. They all are reporting this one. Now, one thing also you have to understand, you can see this all route is showing in the passive. P is your passive. What does mean? Passive means the route is actually your active route. And active means actually it's a something problem with this route. So any route showing in the P, that means it's a valid route. If it is active, that means there is a problem. This route have a problem. So you never consider if any route is showing as active, you suppose in topology table, something is wrong in my topology and this must be need to be corrected. If it is not going to be corrected, it is going to be create a problem for me, right? Now one more thing you have to understand, whenever you configure any kind of the calculation for this matrix, by default EIGRP have some their own matrix calculations, means default EIGRP matrix calculations, that is going to happen based on interface type. Means whatever the interface you have, that is going to play a very vital role to just calculate the matrix. So by default, if you go into for serial interface, that is going to a different matrix. T1 is going to be different matrix. Your Ethernet is going to be different matrix. Your fast Ethernet is going to be different matrix. Your gigabit Ethernet is going to be different matrix. Your 10 gigabit is going to be different matrix. So whatever the link speed you have, based on that link speed, there is a predefined delay values, and based on that, they calculate the default metric. If I talk about the gigabit Ethernet, default metric is going to be 512. Let me show you. So probably in book also we have these parameters. Let me show you. So here you can see every link have some delay by default, depending on the link type. So here you can see now. Yeah, this is what I was talking. So serial link, they are having their on metric. The link is with 64. Default metric is going to this much. T1 is going to be default metric this one. If I want to go for the Ethernet, this is going to be this metric. The fast Ethernet, this metric. Gigabit, this one. Means gigabit Ethernet, this one. 10 gigabit is going to be this one. Sorry, my bad. This gigabit is 2816. This is a default matrix. So whenever you're going through the matrix calculations, this formula is going to be used, and based on that, they calculate the matrix. So whatever the link, you don't have to do any work. By default, EIGRP is going to calculate the matrix based on the interface type, whatever it is going to be configured. Okay. Till here it is good, everyone. Any doubt here?
No, sir.
Okay. Okay, so we have to discuss the wide matrix also. What is the wide matrix concept? Before I'll go in wide matrix, let's do some manipulations in this topology. Let me see one more thing. So one thing, I enable this EIGRP based on the default. That is not correct way. So let me do the correct way deployment of the EIGRP instead of the all EIGRP. So I'll go here. First of all, I'll just remove the default EIGRP. You don't have to do that this way deployment. But I wanted to show the metric, how it is going to be calculated, how this is going to be calculated, the metric, load balancing and all. So what I'll do that, I will just remove this no router EIGRP for all router. I'll just remove. Sorry, I'll go and put the no router EIGRP, and I'll reconfigure the router EIGRP, and how this is going to reconfigure, we'll see that also. Okay. So I did configuration of the EIGRP based on the default route, means default network. But this is not correct way. When you have to the EIGRP configuration, you have to go in the router EIGRP, and the right way, you have to define all network which you want to put in the EIGRP topology table, neighbor table. So I have three network, 14, 13, 12, and the loopback. Fourth is also there. So what I will do that, I will go and put network 12 0.0.0, and I need to put wildcard mask. One network. Another network, I'll go and define 13 as well. Another network, I'll go and define 14 as well. And the last network, I'll go and define the loopback. And this is going to wildcard this one. This is done. So this is the correct way of doing the EIGRP configuration. Now I'll go on the R2, and in this R2, I will go into the router EIGRP 100, and I'll use the network. In this R2, we have the network 12 and 25. So I'll put 12 0.0.0, and this is going to be wildcard mask, and this is going to be 25 also. So see, it is automatically build the neighborship. So 25 also enable, but it is not going to build unless I configure the R5. Now I'll go here and router EIGRP 100 network. In R3 we have the network 13 and 35. So 13 0.0.0, and I'll go here and put 35 as well. I'll do right. And next I'll go R4 router EIGRP 100. So network, I'll configure 45 and then 14. right? You'll see this is going to build the neighborship. Now the last, we have to do the router EIGRP 100, and the network is going to be definitely 45 0.0, and wildcard mask is going to be this one. After that, we'll enable for 35 as well. Wait, this is also going to build a adjacency and 25. And also I enable the loopback as well. So loopback is going to be network 5.5.5.5.
0, 0.
Okay, so this is going to be there. So this is going to be your loopback. Now you will see again, you have the complete show IP EIGRP neighbor. You're going to find all three EIGRP neighbor and show IP EIGRP neighbor. It is going to be there also. Now if you check it again, show IP route, we are going to find the 5 route. It is going to have the best path, and you're trying to ping 5.5.5 with the source 1.1.1. It should be reachable. Now there is one more concept in the EIGRP, that is the passive interface. What is the meaning of the passive interface? Let's suppose I'm enabling the EIGRP for the certain interface. Let's suppose I enable the 0000 EIGRP. Let me put in this way. So if I go here, show run section EIGRP. So understand the passive concept calculations. Here I'll go and let me put it here, no EIGRP, and I'll put the EIGRP, and I'll put the network 0.0.00. By default, this command is going to enable EIGRP to all network. By default, this is going to enable the EIGRP to all network. But for certain reason, you don't want to enable the EIGRP for any networks. So how it is going to be avoided? So we have to put some network as a passive network. And if I am going to put as a passive network, then only it is possible I can avoid the situation. So how it is possible? I'll create the passive interface. Let's suppose I have the 3 interfaces here. I don't want to enable EIGRP on 0/2. So I will put here passive interface gigabit 0/2. The moment I will do that, this EIGRP is going to be down, and this will never create the EIGRP neighborship. So it's better if you designing the EIGRP, sometime you're going to find this passive interface command as well, which is going to help you which interface should not learn and listen your EIGRP packets, and then passive interface is going to solve that problem. So if I go here and so run CSN EIGRP, because of this command, this is not building your EIGRP. The moment I'll remove this command again, it will automatically build your EIGRP neighborship. Clear? So you guys understand what is a passive interface, right?
So passive will be getting the hello packets, but it will not be responding.
Yes,
Or will it?
passive will basically, it is going to be isolate from the EIGRP. It will never reply for anything is going to come to me. It's going to be
Okay.
neighbor, but never going to be adjacent. So there is one more concept in the OSPF and EIGRP. One is the neighbor and adjacency. Adjacency is we are agreed to exchange the full emotions to each other, means full routing table. That's the adjacency. Neighbor means I know you, you know me, but we don't have any talk. We're not exchanging our ideas, our visions. That's the meaning of neighbor. So neighbor doesn't might be neighbor cannot be always have the adjacency, but adjacence always have the neighbor. Means if I'm going to exchange my routing table, database table, so that means you and me are mutually agree and we have the good friendship. Then we are only doing this kind of the discussion. So neighbor is going to be always your adjacence. Adjacence is going to be always your neighbor, but neighbor cannot be. So let me see. I'll go and configure this again. I'll go here. I'll configure this again as a same do route, and it is going to be there. Okay, what else? So we discuss what all discuss. We discuss the metric, how it is going to there calculated. We discuss about the successor, feasible distance, and what we discuss else. Metric. We have to discuss the wide metric tomorrow. I will explain this wide metric concept. What is going to there. And now we have to discuss this is the classic mode configuration. We have discussed how we can design the EIGRP in the named mode configuration as well. So named mode and the classic mode totally different. We have the configuration method. Named mode you have to define not AS number in first format, means when you're going to define the named mode, you just have to go and configure the name first, and then under the name we have to define the AS number. So I'll configure these all tomorrow. All right. Clear, guys?
Yes.
And
Yes.
also what I'll discuss tomorrow, wide metric will discuss, named mode will discuss, and then after what I can discuss tomorrow, let me see. Okay, we'll check the syllabus tomorrow, and then accordingly we'll discuss how we can. We have to discuss the load balancing also. Summarization we have discussed, load balancing we have discussed, lot of things we have discussed. So we'll check every topic and we'll complete one by one. All right, good for today, guys.
Yes.
Yes, sir.
All right, thank you. Bye bye. Take care. See you tomorrow.
Thank you so
Thank
much.
you.
Thank you.
Good night, sir.
Good night,
night.
everyone.
Bye.
Bye bye.